Now then, got a little project here. I'm dragging out the stores, a few panels, and selecting a grid inverter that I fixed a while ago. And the project is to put 4 panels on a small outbuilding roof. The roof is of such a size it will only take 4 panels, so we need to match the panel output voltages with the inputs of the grid inverter. Anyway, so I selected various bits and pieces, put it together, and this is the testing process. So I hope you enjoy this and learn something from it, and I will catch up with you soon for the next video that I'm not sure what it is, but we'll all find out together, will we? Cheers for now. Here we've got 4 panels, and I'm going to wire them in series, and they're a nominal maximum power point of 31 volts as an average. They're all a bit variable, so let's just go and see what the open circuit voltage is for these 4 panels, and as I say, in series. So I've got the meter set on 200 volts DC, and let's just plug the meter into this. There we go, 141 volts DC. So let's just have a look at the specifications for this particular inverter. Okay, the thing we're interested in is the volts maximum power point, MPP, and it's 90 to 100, just knock the camera there, 90 to 520. So I think these panels will run this inverter. Yeah, and the DC maximum current is 12.5 amps. Well, these panels are maximum current of 8 amps, so everything seems quite good. So let's just wire it up. Okay, let's connect the DC in. There it is. That's DC connected, and let's collect the mains connected, and we'll just watch what happens. I think the main thing to watch is here and there. There we go, showing 140 volts DC there and 240 volts AC there, and it's just doing the self tests. Let's just zoom down a little bit there, checking the grid. Okay, this takes a few seconds, and I'm just going to let it roll so you get an idea of what goes on. So it's just testing the grid connection. Yeah, gridded range, and now we've got connecting, and we've got this thing flashing here, DC and AC, and now it's working. There you go. Now if we let it scroll through, there's some interesting features here. That's power out. So we've got temperature. Yeah, peak day 872. Yeah, we've got the average voltage. We've got the grid. And there we go, V in 111, current 8.2, right? And then we've got 851 watts. So we've got 8.2 amps, which is the maximum output of these panels. So if you do your Ohm's law, we've got 111 volts times 8.2 amps will be probably slightly less than 825 because of losses. But there you go, it's working. It's only just working, I suspect. But minimum DC in is 90 volts, so we're not too far away. No doubt in winter it'll be a little bit shabby, but all solar is much reduced then. To improve this, you could always add another panel, because the current would remain the same but the voltage would go up. So the input voltage probably, instead of 111, would be something like maybe 138, 140, something like that. And of course your Ohm's law, 8 times 140 is more. Okay, there you go.